going to take just a little bit of time to use what we talked about in section 8-1 to provide a proof of the Pythagorean theorem. Now, there are many different ways of proving the Pythagorean theorem, but this is just one. Recall our theorem, the leg geometric mean theorem. It states that the length of a leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg when the altitude to the hypotenuse is drawn in a right triangle. So in this particular triangle, we could say that A is the geometric mean between C, the length of the hypotenuse, and Y, the length of the segment of the hypotenuse adjacent to that leg. So that would mean that A is equal to the square root of C times Y. That same theorem would allow us to say that B, the length of the other leg, is the geometric mean between the hypotenuse, C, and the length of the segment of the hypotenuse adjacent to that leg. So we could say that B is the geometric mean, so the square root of the product of C and X. Notice if we square both sides of those equations, we would get A squared equals C times Y, and B squared equals C times X. What I'm going to do next is I'm going to add those two equations together. So in other words, I'm going to add their left sides, add their right sides. I can do that because I'm adding the same thing to both sides of our equation. And in fact, if I show it this way, we have A squared equals C times Y plus B squared equals C times X. Since these two things are the same, I am adding the same thing to both sides of that equation. So on the left side, I would get A squared plus B squared, and that equals on the right side C times Y plus C times X. Since those are not like terms in terms of X and Y, however, they are like terms in terms of C. So I could say, all right, this is really C times the quantity of Y plus X. Kind of using the distributive property, but treating C as the variable and Y and X as the coefficients, that's how we'd find that. But let's go back to our picture. If I add Y and X together, I get C. So instead of Y plus X here, I could replace that with C, and then notice C times C allows us to rewrite that equation as A squared plus B squared equals C squared. So if we have a right triangle, angle C is the right angle. So lengths A and B are the lengths of legs. C is the length of the hypotenuse. We do find that A squared plus B squared is equal to C squared.